Okay, after some technical issues, this is a related rates question from exercise 6W. It tells us that we've got a radar located on the ground vertically below the path of the plane. The plane is flying at a constant height. It's maintaining its speed of that. Find the rate in degrees per second of the rotating radar when. Okay, so just to get a diagram, this is my radar. The plane is flying horizontally like that. We know that this height here is 10,000 kilometers, 10,000 meters, sorry. We also know that and this is the x direction is what it's flowing in. This is my y direction, just so we have that. So dx dt is 1025 km per hour. Now, we are asked the rate degrees per second. So we got to turn that to seconds in order to be able to deal with it. So in seconds, 1025 kilometers per hour, I need to multiply by, actually, I need that to be in both meters and in hours. So let's get it to hours first. And if I switch that, sorry, I'm not going to get to hours first. I'm going to get into kilometers first. So that'd be 1025,000 times, and then to get me out of hours, I need to divide by 60. Sorry, no. I need to multiply by 60 kilometers per hour. Sorry, we are going to get this right, don't you worry. 1 over 60, that gets me to minutes, and then 1 over 60 gets me to seconds. Okay, so just trying that, that's going to get me to meters per minute. So 1025,000 times, I need one more zero there, times 1 over 60 times 1 over 60. That is going to get me that value there. So 725, yes. All right. So my actual dx dt is going to be 5125 over 18. All right, so that's got me to there. Now, the situation that we have set up is that we're starting from 8 kilometers away. So from 8 kilometers away, which would be 8,000 meters, and we're looking for how quickly that theta is changing. So to relate the two of these, I've got opposite, I've got adjacent, we're talking tangent. So the tangent of theta is the same as, well, y is constant. So we can just leave that 10,000 underneath right there. And we've got 8,000 there. So the arctan of 8,000 over 10,000, that's going to give me theta. So in this case, theta is degrees trig. 8,000 divided by 10,000. Thank you so much. So that tells me that I am about 38.7 degrees. Now, when I use this, I'm going to actually use the actual value. but we can deal with that later. Okay, so now I have all of my knowns. Again, just getting all of my knowns written down. We know that x is 8,000. We know that dx dt is going to be 5125 over 8. We also, over 18, sorry. We also know, man, that still seems big. All right, but anyway, we also know that our y is going to be 10,000, and also if we want, it's a constant speed, so it's got a horizontal asymptote. We know that theta is going to be about 38.7 degrees, and the thing that we're after is d theta dt, which is our big question mark. So we're going to go back to the tangent ratio, and we're going to use that tangent ratio of the tangent of theta is equal to 10,000 over x. So that's going to be all of them. We can find that with 10,000 over x. And now I'm just going to take the derivative of this and see what happens. D dt. Well, tangent is secant squared theta times d theta dt. That's good because that's what we're after. And that's going to be equal to, well, the derivative of x is 1 over 10,000 times the derivative of x as units of time. All right, now we're going to sub what we know and what we don't know. So this would, well, actually, let's just d theta dt equals 1 over 10,000 times dx dt we saw was 5125 over 18 over 18, and all of this is going to be divided by the secant squared of 38.7. And this should give us d theta dt. Let's plug and chug. So that was the quantity 1 over 10,000. And I'm multiplying that by 5125 over 18. And then I'm dividing all of that by the secant of I need one more bracket. Yes. So that would tell me that the degree is changing by the second by about 0.017 blah, blah, blah. So that is okay. Pretty confident about that one. Next up, we're going to find what? When the plane is directly above the radar. Okay, well, when the plane's directly above the radar, I'm just going to use my same diagram, just use a different color. We're looking for this situation. In this situation, my theta is now going to be 0. Okay? So when I go to solve this, this is going to turn into, it's that same exact setup where it's going to be 1 over 10,000 times our dx dt, which was 5125 over 18, and all of that divided by secant squared of 0, right? So I can just go right back to here, grab that, and if I put 0 in here, I get 41 over that, which is 0.28. So I hope that that makes some sense. Talk to you.